For our next speaker, we begin with the following premise. Detection engineering is tedious. Agree? But detections of higher efficacy come through cyber threat intelligence and proactive threat hunting. And we'll learn more about this from Huang, a senior security architect in APAC for Cisco Splunk. Welcome, Ray.
All right. Thanks. Hey, everyone. Just a little bit of myself. So I come from a SOC SecOps background, typically blue team, have been around 18 years in this industry. So in terms of where I came from, I'm a hybrid Singaporean Aussie, so still a Sydney sider at heart. So for those of you that, what we call football or rugby, like I'm definitely a Blues fan, so hopefully no Queenslander in the room, right? If you know Blues versus Maroon, what that means. Okay, so there is going to be a bit of an LLM element in my talk today, but I just want to put a disclaimer. I'm not a data scientist. I do not have a PhD in data science. So yeah, I mean, definitely it's just a old school blue team person curious about this space as well, actually. All right. Oops. Okay, so this is the agenda that I'm going to run through today. Obviously, it's as Sunil introduced, detection engineering is full of challenges. We need to level set on that. And then one of the best ways to strategizing detections, of course, we are all in a MITRE workshop. Of course, the MITRE ATT&CK framework is a very good way to strategize your detections and to check for coverage, as well as to identify what your valuable sources for detections are, right? One of the key valuable source of detections is always CTI, cyber threat intelligence. So we're level set on that. And of course, there are many different types of CTI, from your sticks and taxi based to your NLP based threat advisories. So that is obviously not easy for machine processing. So how do we use that and process that using the likes of large language models towards those natural language processing based threat advisories? Okay, so what are the detection engineering challenges? Okay, how many of you in here have a dedicated detection engineering team in your SecOps? Honestly, yeah, I wouldn't expect a few. How many of you are wearing like multiple hats? You're a tier 1 analyst, you're a detection engineer, you're an incident responder, all at the same time, actually. Good. Yeah, so that's a very common problem. I mean, we have lack of resources, and detection engineering is not like something that is quite easy to do. We do have limited skill sets, right? I still see a lot of people just thinking detection is something ad hoc, something like, hey, I have this idea out of the blue, let's create a detection, right? And then probably experience that I saw was like when Log4j was patched for 2 years, MSSP customer of mine still like escalating Log4Shell detections to the same customer over and over again, even though they're patched. I mean, if I were the customer, I was like saying, why are you telling me something that, that have been patched for 2 years, right? So there's no framework, there's no planning. It's still quite ad hoc. That's some of the challenges that I've seen. And then analyst fatigue is always real. Like probably analysts gets overwhelmed with all these noisy detections. They are probably getting smashed and they are tired. So some of these are duplicated, and a lot of those, as I say, are expired and irrelevant detection. So these are some of the common challenges that I see as I consult with different organizations out there today. Okay, so in order to have a proper detection engineering practice, right, we need to have a proper life cycle. So this one from Forrester is actually a very good one that I have. Is always whether you like it or not, it's continuous. You don't do it once and forget, right? It's not easy, but definitely you need to discover your gap, right? As usual, how do we prioritize, right? So just like all this talks about submitting the pyramid focus on the tactics, techniques, and procedures, the TTPs, obviously based on pyramid obtained by Mr. Bianco, who is a co-worker of mine. Of course, everyone knows that. Okay, and then obviously match that to like TTP-based framework. So of course, MITRE ATT&CK being the preferred one, not the first one. I have to say that, of course, but that's true actually. So It's always discovering it, TTP based, try to identify your coverage. What are you focused on? What industry based on what APTs you are interested against? Like build that detection. Obviously test it. We had a lot of talks about adversary simulation and so forth. So we need to test it. And when I say testing it and building it, right, it's not just with detection engineering team. It's not just about detecting. It's also like identifying how to respond to it. What is your runbook? What do you do when you see that detections, right? So you need to collaborate. Collaborate with your analyst team, with your incident response team, with your threat hunting team, with your even beyond the SecOps team, like your system owners and application owners. Because at the end of the day, if I see a detection, I don't know what to do with it. That is probably not a very useful detection by itself. And then it needs to be determined and approved, and then you deploy it and you test it continuously, right? What I mean by testing continuously is like always gather feedback, have this weekly or monthly or quarterly cadence with all your key stakeholders, especially your SOC team, like what are the top 10 noisiest detections? How can we tune them? Or even the bottom 10 detections that never trigger off, right? It could be because of like, as if like something never happened in that environment, or it could be just misconfiguration that it was wrong all the while, right? Or it could be duplicated that you want to consolidate multiple detections into the same detections as well. Okay, so this is actually like how, personally, how I feel that we should plan detection coverage. So obviously, is as the talk from Charlene and Joshua just now is you should look at a good coverage across. Of course, filters are your friends, right? Filter on specific things that you are concerned about, specific industries, specific applications or systems that is relevant to your environment, specific like APTs that you and your peers are being impacted with, right? Which you learn from things like adversary simulation, right? And obviously compare that with what you have. Like, as I say, writing detections from scratch is good, but always like, as with many vendors or with Sigma rules, we have like, someone has already written that detection for you, right? You don't need to write it from scratch. Just use what you can see out there, but build on top of it, modify it accordingly. It's better than trying to crack your brain and writing it from scratch. And then whatever you have, color code it against like what you have, and also color code it with what data sources that you have against the kind of TTPs that the detection is based on, right? So obviously focus on those that you do not have security controls with. So where you do not have security controls, you want to focus on those more against those that you have security controls, because obviously you don't want to enable like thousands of detections all together at one shot. No analyst will be very happy with you for that. You want to focus and prioritize, right? You can only do so much at once. Okay, so as I said, CTI is a critical input, right? Because we don't know what we don't know if we don't look outside. We need to know what's going on with our peers, what is going on with our industries. We need to compare that and compare it against like our own situation awareness, like based on our understanding of our own environment, our risk impacts and mitigations. And it's a way to do preemptive defense, right? Like you want to defend against a threat before they really become an incident in your environment. And of course, subsequently, by reducing the exposure, reducing the risk, you prevent that financial loss prevention to your business as well. Okay, and CTIs, there are many different types. As I said, the technical and tactical, those are like your sticks and taxi format. Maybe the tactical is like with that format with some TTP enriched. Those are easy to ingest and can be easily automated for machine interpretation, right? But then again, we talk about the operational. So those are more like advisories. But probably operational is the ones that has more IOCs and TTPs mentioned against it in specific format, but it's still in plain human language, like plain English or Japanese or Korean or whatever. So easy for human to understand, but as we know, what's easy for human is hard for machines, right? And then the strategic ones are like your threat reports for your executives, for your CISOs, right? Very vague, probably a few sentences. but it doesn't mean that they are meaningless as well, right? So we cannot disregard that type of intelligence as well. So I'll focus how to deal with those two types today. Okay, so this is an example of the later two types that I was talking about. So probably that is more of the strategic one. The one with this is one that is good, probably written by our search team. So it has the narrative. It has like in tabular forms, like what techniques and tactics is being used, what IOCs, even the procedures as well, right? But how many of you actually receive a lot of that type of advisory? Probably just a few sentences. I mean, probably sometimes we don't always submit to premium CTI feeds. Sometimes we use open source. I mean, I'm not saying this is bad. This is from the Australian ACSC, but yeah, I mean, it's probably a few sentences. You can kind of human interpret it, but then it's hard for the machine to understand and convert. So this is something that I've been experimenting using quite a few different machine learning models like LLMs to play around with this. So in terms of what I've been doing, like for the training data sets, of course, I use some of the MITRE ATT&CK pages. So similar to that NEC talk earlier, like looking at the MITRE trend as the base of that and improving the Skybird model out of it by expanding the techniques involved in that. Also the inputs, like using the detection documents. The detection documents means like whether it's Sigma or in my case, it's the Splunk ESU contents, the description narrative of that, as well as the actual rules that is related to that detection document. So these are the inputs that are used. And some of the models that I use are the MITRE Predict Skybird based on the MITRE track, MITRE trend, as mentioned, and that's to use to identify the closest MITRE technique. And then simpler T5, obviously that can be improved, but that's to identify using decoding and encoding and decoding, like using the description against the relevant, like SPL in my case, or the actual Sigma syntax, and then trying to identify and predict or translate the detection, the SPL detection that can be used for that particular detection. And lastly, semantic analysis, because just so happened, luckily enough, with my detection library, we actually annotated based on this security domain categories like DNS, AWS, and so forth, right? So this method is actually used for traditionally e-commerce and consumer industry, where you have different categories of customer, and then you try to classify them and set them into different clusters according to those categories. And based on your inputs to the model, right, it will try to identify based on the language, the closest cluster, and then from there, try to learn like the top few detections that could be used from that cluster rather than processing through the whole thing itself. So what are some of the results that I've gotten based on this experiment? So using this tactic for the first set, obviously that's very similar to what MITRE trend is doing. I broke down into the sentences, predict the relevant like MITRE technique from there, and then from this one we can then redirect to, based on my existing detection libraries, what I can actually potentially use from there. Obviously can be expanded further, but this is just my current experimentation as well. Number two is like taking that same advisory, summarizing them by sentences and tokenizing them, and then based on that simple T5 translation, identifying the closest SPL that I could use to detect that kind of behavior on this, right? And as you can see, that's the bigger part, the summarized sentence versus the suggested detection rule syntax. And of course, with any AI, you need the human in the loop. You still need to use your interpretation of that as a human. And finally, last slide, that semantic analysis, because of the classification, with that language, I managed to identify the contents, and then based on the detections across those categories like DNS or web or whatever, right? Find the closest category and suggest the the top 4 suggestions for that particular sentence by itself. So probably what is next, a lot of talks gave me the idea today. So obviously the MITRE tie is the next one that I may look at, but on top of that, just probably my vision is to have that MITRE tie to obviously use that LLM to suggest the whole incident runbook, the response plan based on that MITRE tie as well. So with that, yeah, these are the key takeaways. Detection engineering is difficult, but we should understand the challenges in order to do them better. CTI, always use CTI and never disregard those human readable, non-technical advisories because we can use LLMs to help interpret them when used correctly and trained correctly. But of course, we just covered through 3 examples of that, and the sky is the limit, is limitless how you can do that actually. All right, so that is my contact. If anyone wishes to connect with me, I'm happy to discuss and collaborate on this. Thank you.